Let us do question number 22 from the book. Okay, the question number 22 is integral of secant 4x dx. There is only one trig ratio, so the easiest way is, because secant has, you know what is the derivative of tangent? Secant square, right? So you want to break this into square and square, so it will be like, so this can be written as secant square x times secant square x and then dx, right? But you know what is the formula for secant square? I want to change one of the secant square into tangent so that I can set up tangent equals to u. So I want to do 1 plus tangent square x times secant square x dx. You see that? So I write this way. So you should be thinking on, oh, how should I break that secant 4x in such a way that, so I'll get two different functions, okay, and then if I set one of them equals to u, and the derivative of that will be the remaining function. You should think that way, okay? So what I'm going to do is set tangent x equals to u. What is the derivative of tangent? Secant square x dx will be du. So what is the integral? That integral can be written as 1 plus u square times du. You see that? Secant square x dx will be du. So what is the integral of that? Then u plus u cubed over 3, right? And then plus c. So you don't need parentheses actually. So that can be written as, what is u though? U is tangent x. So it is tangent x plus 1/3, and then you can write tangent cube x and then plus c. That is the final answer. Okay guys, so that's how you do the question number 22 from the book. Now the next problem I want to do is question number 24. So question number 24, the question is, it says tangent to the 6th 3x, integral of tangent 6th and then 3x and then dx. That's what you have. Okay, for the tangent, how would you break that tangent into two terms? Okay, so the idea here is, what I want to do is, let us break this into like tangent 4 3x times tangent square 3x dx. Let's do this way. Okay, so how do I do this then? That tangent square I want to change into secant square minus 1. So that can be written as tangent 4 3x times, this will be secant square 3x minus 1 and then dx. Right, now let us distribute that. What do you get? You get integral of, you can write tangent 4 3x times is secant square 3x dx minus, you can write tangent 4 3x. What did I do here is I'm distributing this tangent 3x to secant square 3x, and then so tangent 4x times secant square 3x minus tangent 4x times 1 is that one. You see that? So what is next then? So what I'm going to do is, I want to write that tangent 4 as tangent square and tangent square again, but here I want to keep that. Why? Because if I say tangent equals to u, then you will get secant square x dx will be du, right? So this first integral is okay. I want to copy that tangent 4 3x times secant square 3x dx, and then minus, for this one what I'm going to do is, I'm going to do tangent square and tangent square, but that one of the tangent square I want to write secant square minus 1. So I want to write like this, tangent square x times secant square x minus 1, like this. Okay, and then there is dx. Okay, so how do you write this then? So you can write this as tangent 4 3x times secant square 3x dx minus, so let us distribute that tangent square. You will get tangent square, oh by the way there is 3x, okay, 3x and there is also 3x. Tangent square 3x times secant square 3x, and then what? Dx minus, now tangent square 3x times 1 will be integral of tangent square 3x dx. So I'm just distributing and then separating the integrals as well. I'm separating. You can always separate the integrals for the positive plus and minus. Alright guys, so what I'm going to do here, again I want to write the tangent square as secant square minus 1, because I know what is the integral of secant square, that is tangent square, that's why. So let me write one more time and then I will do the u substitution. Okay, so this will be tangent for 3x times secant square 3x dx, that's the first integral, minus integral tangent square 3x times secant square 3x dx minus, so how do you write that one? That will be integral secant square 3x, right, minus 1, and then dx is outside there. Okay, now set tangent 3x equals to u. Then what is the derivative? You get secant square 3x times 3 dx will be du, because what is the derivative? It is like a tangent u, right? The derivative of tangent u is secant square u times u prime. That's why u prime is 3 there. So if you set that as u, right, tangent u, the derivative of tangent u is, what is the derivative of tangent u? Tangent u prime. U prime is equals to secant square u times u prime. That's what you get. Okay, so what is secant square 3x dx then? Because we have secant square 3x dx here, secant square 3x dx also. So that will be 1/3 du. So what is that integral looks like? This will look like integral, and then you can write u to the 4th times 1/3 du. This is tangent 4th is u to the 4th, and then secant square 3x dx will be 1/3 du minus integral, that will be u square times 1/3 du. Does that make sense? Because I'm writing that as u square, and this is 1/3 du minus, what is the integral of secant square u? Secant square 3x, that will be tangent 3x over 3 minus 1, that will be minus x. Okay, so what I'm going to do is I'm finding the integral of that as well. So how that look like? Let me write down that. So that will be, let me move that, equals to, so what is u to the 4th? That is 1/3 u to the 5th over 5. You see that? And then minus, that will be 1/3, and then you can write u to the 3rd over 3 minus 1/3 tangent 3x minus x plus c, right? Now plug in the value of u. You get 1/15 tangent 5th power 3x minus 1/9 tangent 3rd power 3x minus 1/3 tangent 3x, and then minus x plus c is the final answer. Okay guys, so it was a little bit long, but it follows the same techniques, right? But you need to know that you need to know that which one should be u, and then if there is only one trig ratio, then you need to break that into the 2 trig ratios. So you need to know whether do I need to do, like on this one for example, do I need to do tangent to the 5th and then times tangent to the single power, or tangent to the 4 times tangent to double power? It will be single power, double power, because it is tangent to 4 and tangent to the square. So that tangent to the square can be written as secant square minus 1. That's why we were doing that. Okay, and then secant square can be written as that the derivative of the tangent will be secant square. So it will be used later. That's why we did that way. Okay, guys. Let us do question number 27 from the book. Number 27. It is tangent cubed, integral of tangent cubed twice t times secant cubed twice t and then dt. Okay, that's what we are going to do. So here, so this is a little bit again, so whenever you do new problem, you will always learn a new skill on that problem, because all the problems are a little bit different and you will learn new skills. Okay, and here both of them are odd. What do you think? How should I break it? Because I know what is the derivative of secant x. Do you know that? The derivative of secant u, let's say secant u prime, what is that? You know that? It is secant u times tangent u, right? That's what the derivative is. So what I want to do here is, because there is like odd exponent here, okay, since there is odd exponent for both of them, what I want to do here is I want to write this as like, I want to write tangent cubed as tangent square twice t times secant square twice t times, I want to do secant twice t and then tangent twice t and then dt. So my plan here is I want to write secant twice t equals to u, so that the secant twice t tangent twice t dt will be du. That's my plan. Okay, so here, so I need to change everything in terms of secant. So what is the formula of the tangent in terms of secant? That will be integral secant square twice t minus 1. That is the tangent square twice t, right? Times, that is secant square twice t times secant twice t times tangent 2t and then dt. Okay, so what I want to do is set secant twice t equals to u. Then what is the derivative? Secant twice t times tangent twice t and then dt will be du. So that thing, oh, by the way, that is secant twice t tangent twice t times u prime. That is the formula of the secant. So secant u, derivative of the secant u will be secant u times tangent u times u prime. So what is the u prime? U is like, here you see that secant, that thing, the prime of that is times 2. Okay, let me write on 2 here, 2 times. So that is basically secant twice t times tangent twice t and then dt will be 1/2 du. That's what you will get. Hence you can write that integral is equals to, this is like u square minus 1 and this is like u square times, that will be 1/2 du. See, the problem reduced to very easy problem here. So I want to write 1/2 and integral u to the 4th minus u square. I'm distributing that to both of those and then du, right? What is the integral there? 1/2, it is u to the 5 over 5 minus u to the 3 over 3 plus c. Now plug in the value of u. 1/2, what is u to the 5? U to the 5 is secant to the 5th twice t over 5 minus u to the 3 is secant to the 3rd twice t over 3 and then plus c. That's what you get. Okay, that is the final answer. So the next example I want to do is let's say question number 31. I want to do question number 31. Okay, number 31 from the book. It is integral of secant 5x, integral of secant 5x times and then tangent 3x, tangent cube x, x dx. Again, both of them are odd, so we need to do the secant. You see that when both of them are odd, you need to try to change into secant, and then secant tangent will be the derivative. Okay, but if both of them were even, then at that time you would try to change the derivative of tangent, so you try to change into the tangent format. Okay, so what I want to do here is basically I want to write down secant 4x. Okay, and write down secant 4x, and then I want to write down into secant tangent square x, and then secant tangent at the end. Okay, that's my plan here. So that will be equals to, I want to write secant 4x times tangent square x times secant x times tangent x dx. Okay, now I'm assuming secant x equals to u later, but I need to write that into secant format too. So it will be like secant 4x, okay, and then times it will be secant square x minus 1 times secant x times tangent x and then dx. So you need to do set secant x equals to u, then secant x tangent x dx will be basically du. See that? So that can be written as u to the 4th times u squared minus, it is similar to the previous one, right? Even easier than that, times du. Isn't that easy? Okay, so that can be written as, you can write u to the 6 minus u to the 4th and then du. I'm distributing that, right? So what is the integral of u to the 6? U to the 7 over 7 minus u to the 5 over 5 plus c, right? So that can be written 1 over 7. U is, so secant 7x minus 1 over 5 and then secant 5x plus c is the final answer. Okay guys, let me do number 33. Okay, and then this is 33 is should not be very bad problem. So what I want to do is I want to do number 33. Okay, let me write down, let me move that a little bit and write number 33. It has the quotient, it is like secant squared x, tangent squared x over secant x. Okay, so tangent squared x over secant x and then dx. Okay, how do you do that? So this should be, you can write that tangent as secant squared x minus 1 over secant x. Again, there may be more than one method to do that, but you will get the answer same either method you follow. I want to split the denominator. What do you get? You write secant squared x over secant x. It will be the secant x minus 1 over secant x will be cosine of x dx. Do you remember what is the integral of secant x? That is natural log of secant x plus tangent x, right? And then minus, what is the integral of cosine x? That will be sine x plus c. That is the final answer. Okay, so the next video I will contain couple more examples and that will be the end of section 8.3. So in the next video you will see couple more examples from section 8.3. Okay guys.